we will learn how to determine whether an ordered pair is a solution of equation, how to complete ordered pair solutions of equations, how to construct a table of solutions, and how to graph linear equations by plotting points, and how to use graphs to solve applied problems. Let's focus on logical path to determine whether an ordered pair is a solution of an equation. As you remember, when we had linear equation in one variable, in most situations we expected one solution. Now we are working on linear equation in two variables, and to our surprise we will see that linear equation in two variables has infinitely many solutions, and if we plot some of them and connect them, then we will see a graph which is straight line. So all solutions of linear equation would be on this straight line. Point which is out of straight line would not be a solution. Or we can say, if point is not on the line, it's not a solution. Now, when we have to answer the question about point, is it solution or not of equation, how can we answer this question? We have two options. The first one is to graph, and if point is on graph, then this is a solution. Second option, we can use an equation, and if we replace x and y by corresponding numbers and check, is left side equal to right or not? If it's equal, then it's a solution. If it's not a solution. Modeling for linear equations in two variables. Here's two baskets, and those baskets on scale, and scale is on balance. Now we have red apples and golden apples. Now we are going to add one red and one golden, one more red and one more golden, one more red and one more golden. As you see, basket in balance. More, 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 and baskets in balance. Now we can take one red and one golden, take a nice bite, and return what is left over. As you see, baskets on balance. For left baskets and for right baskets, let's use blocks, and X represents red apples and Y represents golden apples. As you see, number of red apples equal exactly number of golden apples. X equal Y is a linear equation in two variables because we have X, first variable, and Y is the second variable. In rectangular coordinate system, I'm going to plot several points. The first one, 0, 0. Second one is 2, 2. Next one would be 4, 4, 6, 6, and then 8, 8. Negative 2, negative 2, negative 4, negative 4, and negative 6, negative 6. I want you to look into coordinates for each point. 0, 0, 2, 2, 4, 4, 6, 6, 8, 8. And do you see relations between x coordinate and y coordinate for each point? Each y equal x. If x is 4, y is 4. If x is negative 6, y is negative 6. Now you can see this as a linear equation in two variables because we have x variable and y variable. And if we connect our points
we can see a graph which is straight line. Now let's talk. What does it mean, straight line? Straight line is location for infinitely many points, and each point on this line is a solution of equation y equal x, because for each point on this line, relation between x and y coordinates reflects y equal x. If x equal, for instance, 1.3, y coordinate for that point would be exactly 1.3. So linear equation in two variables has infinitely many solutions. And if you plot those solutions, or some of them, and we will see a graph which is straight line, but those points are standing so close to each other that you don't see opening. This is why you can see a solid line. But solid line is a location for points which are solution of an equation in two variables. Modeling for another linear equation in two variables. Again, our two baskets, and this time we have red apples, green apples, and golden apples. Now we have 3 apples in left basket and 3 apples in right basket. But in left basket we have 1 red and 2 green. We are adding 1 more apple to both baskets, 1 more, and now I want you to see that number of golden apples is always 2 more than number of red apples. And if we take a bite from those apples, then we can see again that number of golden apples is 2 more than number of green apples. Now, if x represents number of red apples and y represents number of golden apples, then relations between red apples and golden apples would be x plus 2 equal y, or number of golden apples is always 2 units greater, 2 units more than number of red apples. Algebraic approach. Here is point with coordinates 0, 2. Next would be 2, 4, 4, 6, 6, 8, negative 2, 0, negative 4, negative 2, and negative 6 and negative 4. If you look into coordinates for each point, we can see relations between x and y. As you see now, we can show relations between x coordinate and y coordinate for each point as y equal x and positive 2, or y is 2 units greater than x for each and every point. Now we can say this is linear equation in two variables, because linear equation in two variables always show relations between x and y variables. Those relations can be very simple, like in previous case, y equal x. More complicated, like in this case, y is x and positive 2, or can be very complicated. But linear equation in two variables always reflects relations between two variables, x and y. Now, if we connect those points, we will see graph which is straight line. For linear equation, graph is always a straight line, and graph is location or solution of corresponding equation. So this line is bunch of points, infinitely many of them, and they are standing so close to each other that you don't see openings, and each point is a solution of this equation. For instance, if x is 1, then y would be 3. Not 5, not 10, but just 3, because y is supposed to be 2 units greater than x. If x is, for instance, 5, then y would be, what do you think? Yes, y would be 7, because each y is 2 units greater than x. Points on the graph are a solution of this equation. So points out of the graph, they are not. The point with coordinates -4, 4. Is this point a solution of equation y equal x and +2 or not? No, it's not. Because to be a solution, if x is -4, y is supposed to be -2. So this point, red point, is not a solution because it doesn't reflect relations between x and y. And therefore this point is not on the graph. And second point, red one, the same verdict. It's not a solution because this point does not reflect relations between x and y. For x equal 4, y is supposed to be 6. So this point is not a solution, therefore this point is not on the graph. Determine without graphing whether the given point with coordinates -5 and -4 is on the graph y equal x and +2. Analysis. To be on the graph, point supposed to be a solution of the equation. So now let's copy our equation and we have to check if we substitute x for -5 and y for -4, is left side equal to right side or not. If left side equal to right side, then yes, this is a solution and then point is on the graph. If left side is not equal to right side, then this point is not a solution, therefore this point is not on the graph. In this case, what we have, left side is -4 and right side, if we simplify, -5 and +2, what will be -3. So left side is not equal to right side, therefore this point with coordinates -5 and -4 is not a solution and this point is not on the graph. Now we want to check our conclusion. In this case, we can check our conclusion by drawing the equation y equal +1x and +2. So we will see graph, and then we can plot point with coordinates -5 and -4, and we can see very clear where the given point -5, -4 is on the graph or not. As you see, the given point is not on the graph, so our conclusion is correct and we can write the answer. The given point with coordinates -5, -4 is not a solution of the equation, therefore this point is not on the graph.